Hello again everyone, welcome back to ptet.chemistry channel. So in this tutorial video, I'll cover this work 2 that has been assigned for students doing the 5129 combined science chemistry section. And the syllabus has undergone a big revamp. This is for those taking the 2023 exams. However, atomic structure is a core topic, and this is actually the exact same content that O-level students doing the pure chemistry are actually doing as well. All right. Anyway, so looking at this first question, these are a set of multiple choice question. Multiple choice are really good because it's not a random choice. So students often didn't do very well because they thought it was easy. But in reality, they should really think through the problem and try to solve it by using all the information and writing on their question paper, circling, underlining whatever is important rather than just reading, because we are not very good at just reading. In fact, I am a very careless person. That's why you see me always writing and circling and underlining. Okay. So hang on, something is wrong with this. Something is wrong with this question. I think this question is wrong actually because it says phosphorus is 15 proton number. When it's written like this international format, this is called proton number or atomic number. This should be proton number or atomic number. As you know from periodic table, phosphorus and phosphorus are the same element. It cannot be phosphorus and phosphorus. I believe this one is sulfur. Okay, so if you cross this out, this one must be 3216 sulfur. Sulfur is element number 16 in the periodic table, so you can change that, otherwise it wouldn't make sense at all. All right, so 3216 sulfur. I better write it a little bit bigger. In this international nuclide notation, which is how question always give you, which is how you should write it, it's not the same as the periodic table. The periodic table shows you the number in the middle, in the other way around, but the international nuclide notation shows you to the far left. The number at the bottom is the proton or the atomic number. The number on top is what you call nucleon, or you call it mass number. So nucleon number is equal to the number of protons and the number of neutrons. So you sum them up. And where are they? The protons and the neutrons are in the nucleus of an atom. So if I were you, I would set up a table, an imaginary table. P plus for proton, electron is E minus, N for neutron, not nucleon. Nucleon is this number, and they refer to neutrons. Okay, so be very careful. Nucleon is both the proton and the neutrons. Nucleon is both the proton and the neutron. Neutron is just the neutron on its own. Number of proton is 15 for phosphorus, 16 for sulfur. These are atoms, so they are atoms. So number of proton must be equal to number of electrons for the charges to be balanced out. Protons have a charge of +1 for each proton. Electrons have a charge of -1 for each electron. These are stated in the syllabus. Candidates should be able to state the relative charges, state the relative masses of proton, electrons, and neutrons. 3 marks when you fill in the table. Okay, everything. Number of neutron is going to be the nucleon number or the mass number minus the number of neutrons. Those are your simple primary school mathematics. So 31 minus 15, put it into your calculator and you will get 16. And then this is 32 minus 16 and you will get 16 neutrons. So what is the same? What is the same? Nucleon number is not the same because 31 is not the same as 32. 31 is not the same as 32. Number of electron is not the same. 15 is not the same as 16. Number of neutrons are the same, 16 neutrons there. Okay, number of protons are not the same because different element. Different proton number means different element. That is what your periodic table is all about. The next one, you have 3517 Cl. So number of proton is going to be 17, and if number of proton is 17, you only have one answer. There's no need to go through other option because number of protons is given by atomic number or proton number. There's no other 17 in the other option. The number of neutron is 18. You don't even have to check it because there's only one answer there. But you can check it. The number of neutron equal to mass number or the nucleon number minus the proton or the atomic number equal to 18. What is nucleon number or mass number? Is the number of protons and the neutrons. Okay, you sum them up. Nucleon number is the number of protons plus the number of neutrons in the nucleus of an atom. Candidates should be able to define this as stated in the syllabus. Aluminium is 27, 13 aluminium as shown there in this nuclide notation, not in the form the periodic table has shown you. So make sure you know 13 is proton or the atomic number. The other name for proton number is atomic number. The other name for mass number is nucleon number. Nucleon, or you call it mass number. So number of proton is going to be 13. So D is out because there is 14. Number of electrons for an atom. Atoms is uncharged. So number of proton equal to number of electron. So it must be 13 and not 14. So you only have one answer there, which must be B, because these and these are wrong. And I can cross out A and C. Alright, so this is how you do multiple choice. It's not a random choice. If you make random choices in life, you're not going to get anywhere. Therefore, you need to know how to get to the correct answer. That is more important. Number of neutrons is going to be the mass number or the nucleon number minus the proton number. 27 minus 13 equal to 14 neutrons. Alright. Again and again, you see that question really like to ask you what is meant by nucleon number. This is the nucleon number because this is the international nuclide notation. The number at the bottom is the proton or the atomic number. So 23 is the answer, straightforward there. Which diagram shows you the structure of an atom for 7,3 lithium? Number of proton is equal to 3 because proton number at the bottom for the nuclide notation for the international standard. Number of electron is 3 because it says an atom. Number of neutron equal to the nucleon number, which tells you number of protons and the neutrons. It tells you the number of proton and the neutron. You take away the number of proton, then you get the number of neutrons. Okay, so it's not very clear there, but I hope you can see there are 3 proton and 4 neutron. 3 proton and 4 neutrons, so there are 7 nucleons. And where are the nucleons? The nucleons are in the nucleus of an atom. The electrons are orbiting outside the nucleus in shell. These are electron shell, first shell, second shell. Okay, so altogether, let's have check the proton first. There are 3 proton. There are 3 proton here. So this is 3 proton. This is 4 proton. This is 3 proton. This is 4 proton. So 4 proton already is wrong. And you have 3 electrons because you are talking about atom. Atoms are uncharged. Number of proton must equal to number of electrons. Altogether, this is total, yeah? 2 electron plus 1 is 3. Okay, so 1, 2, 3. You have 1, 2, 3, 4. C is wrong because, okay, because you only have 3 electrons. So A must be the answer there. Okay, so count, look at the question, read, write, draw, whatever it takes. Okay, next bit, you have this nuclide notation. So number of proton equal to 37. So always set up your imaginary table like this. Make sure it's calculated as well as make sure it's written out and label. Okay, electrons are not inside the nucleus. They want the nucleus. Electron is in shells. They are outside. So how many neutrons I have? Mass number or the nucleon number, take away the proton number. 81 minus 37 is 44 neutrons. So I have 37 protons and I have 44 neutrons. Okay, so this is incorrect. You have 81 nucleons. Nucleons are both the protons and the neutrons in the nucleus of an atom. Electron is incorrect because electrons in shells around nucleus. This is syllabus statement number 1, the very beginning of atomic structure. When you revise based on your learning objective, based on the syllabus. Okay, there's no point reading a lot when you can't even master the learning objective, which Cambridge said candidate should be able to do. Number 8, strontium has an isotope of nucleon number 90. Okay, so look for strontium. Strontium is going to be group 2. Okay, so strontium in group 2, if you have a look at the periodic table, it has a symbol SR. SR is an element number 38. Given in a periodic table is the other way around, because this is the nuclide notation to the far left, not the periodic table. Okay, nucleon number or the mass number we write on the top left, so that's 90. So now we have that, we can work out number of proton is 38 because it's element 38, so D is out. And I have an atom, so therefore the electron must be equal to the number of proton, which is 38, so C is out. And then the number of neutron is the nucleon number minus the proton number. So 90 minus 38 is going to give me 52. Alright, so between A and B, only B is correct for all of them. Number 9 is your definition of isotopes. Okay, so isotopes have the same protons, same number of protons. However, it has different number of neutron. Different number of neutron is correct. Different number of neutron is correct. But it says same number of electrons and protons, but differing number of neutrons. So A is actually correct. This one says same number of neutrons, which is incorrect. Okay. Why is C incorrect? Because it says same number of neutrons. Again, incorrect. Okay. It says same number of proton, electron, and neutron, which is incorrect. A is the best definition there. Moving on to question 10. So this is in the syllabus. Candidates should be able to state the relative mass, state the relative charge of each of these. Okay, so this number is quite difficult to remember. If you are asked to fill in the blank, you can fill in 1/2000 and it's definitely correct. Okay, because this is a small number, quite a random number as such. This is more exact than this, but 1/2000 is as good as an approximation to this very small number. The relative mass of a proton and a neutron is the same, but the relative charge has sign, so you must put a +1 to show the sign. The sign of an electron, okay, has an opposite charge. That's why you see in all my previous calculations, I like to remind myself because I'm very forgetful. Protons are positively charged, electrons are negatively charged, neutrons are uncharged. Okay, neutrons have no charge. Next bit, define as stated in the syllabus. So it is the number of protons and the neutrons. So it refers to number, it doesn't refer to the particle. Yeah, it refers to how many number you have of the protons and neutrons. Where are they? They are in the nucleus of an atom. And if you see the syllabus or your learning objective from your lesson notes, as you could see from the previous lecture tutorial, which of course you read, which of course you use, which of course you revise on. Okay, so bromine is element 35 in the periodic table. This is what you call the nuclide notation, which is the international standard. So written on the far left at the bottom is going to be the proton number, or you call it atomic number. On the top left is what you call the mass number, or you call it nucleon number. So they want the values. Be very careful. They do not want you to put the label. They want the values. So element 35 means proton 35. And then this isotope of bromine, not from the periodic table, read the question. This isotope of bromine has 35 proton. So you have 35 protons. Protons are in the nucleus of an atom. Neutrons are also in the nucleus of an atom. So for A, how many nucleon you have is going to be 35 plus 44, which is 79 nucleon. So the way you will write it will be 79, and 35, and then Br. 35 protons in the nucleus together with 44 neutrons will give you 79 nucleons, because nucleon number tell you the number of nucleons, because it tells the number of protons and the neutrons in the nucleus of an atom. Okay, so next bit is to do with definition of isotopes. So isotopes are atoms of the same element. In fact, they are different atoms. They are not the same atom. They are different atoms of the same element. What do they have? They are the same. That have same number of protons. So they have the same number of protons because they are exactly the same element. They are exactly the same atoms. But what is different? Different number of neutron. That is very important. Not nucleon, but neutrons. Alright. Next bit, you have isotope X. This is 28. This is 30. The number of protons have not been told to you, but you are given the number of electrons. So for an atom, the number of protons must be equal to the number of electrons, because atoms do not have overall charge. So the charges of proton and electron must cancel out. As you know from whatever the syllabus say, candidates should be able to state each of these things. So 14 electrons would mean you have 14 proton as well. They are different atoms. Isotopes are different atoms of the same element. So same number of protons, therefore same number of electrons, because both of them are atoms of the same element, but different number of neutron, because the nucleon number here is 28. So it's going to be 28 minus 14 is 14 neutrons. Okay, so use the periodic table to identify. Identity of an element is given by its atomic number, which another name for it is called proton number. If you have 14 protons, that means you look for element number 14. Therefore, it's silicon, Si. Alright. Number 12, the last question in this work. Atoms of the same element with same proton number but different nucleon number. Therefore, different number of neutrons. This is going to be called isotopes. Okay. So this is the nucleus of a 11 boron atom. 11 there is the mass number, or what they call nucleon number. So you have 11 nucleons. So if you have 11 nucleons, how many of the white one you have? You have white one and you have the black one. The white one you have 1, 2, 3, 4, 5. The black one, the darkened one, you have 1, 2, 3, 4, 5, 6. Alright, so 5 plus 6 equal to 11. These are inside the nucleus. Nucleons refer to the protons and the neutrons in the nucleus of an atom. 11 boron. If you look for boron in the periodic table, boron is element number 5. So proton number is equal to 5. The other name for proton number is atomic number. So, 5 and 6. So what does it have that is 5? So that means this one must be proton. Okay, because there are only 5 of it. And this one must be proton because this is boron. Identity of boron is element number 5. It's got 5 proton and not 6 proton. 6 proton is carbon. 5 proton is going to be boron. So the unshaded one is going to be proton. The bolded one is going to be neutron. Okay, so draw the electronic structure. So you need the electronic structure. That means to show the electronic configuration. So for the atom of boron, you will have 5 electrons because you have 5 protons. Going across the first row of the periodic table, the first row of the periodic table, you have the first shell. So there are 2 elements in the first row because the first shell can only fit 2 electrons. You have 5 electrons, so after 2 electrons, you have to fill in a new shell. You have 3 more electrons to fill in. Boron is in group 3, but is in period 2. First shell, period 1. Second shell, period 2. Boron is a period 2 element. It's found in the second row of periodic table. It has got 3 valence electron. 1, 2, 3, because this is in group 3. Have a look at the Roman numeral. It's in group 3. It's got 3 outermost shell electron. It's got 3 valence electron. Your syllabus says the group number tells you how many valence electron you have, whereas the period number, period 1, period 2, tells you the position, which row of the periodic table boron is found in. Okay, so that's it in this tutorial video. And yeah, make sure you actually revise in your own time and not just rely on these tutorial videos, and make sure you recap the syllabus completely and not miss anything that Cambridge said candidates should be able to do. Alright, so good luck with your revision, and I'll see you in the next tutorial video. Grab me in school if you got any question.